Let me tell you about dry runs and diffs, which is new stuff. The last few versions of Kubernetes, starting with 1.13, have this new option that allows us to see what we're going to change before we change it. And we've seen that before. I've showed you a couple examples earlier in the course, but this method of using it with the apply command is new and better. So what we had in the past was we had a dry run, but it was only on the client. The client didn't actually talk to the server to say, hey, are these resources already there? Do I need to recreate them, or are they going to be updated, or what's going to happen, right? That didn't happen before. So now there's a server dry run option that will send our YAML to the server and compare, figure out what needs to actually happen, and then report back to the command line what's going to change. So let's see that in action. I'm in the K8's YAML directory like I discussed earlier in a lecture. If you are in Docker Mastery's repo and you don't have this directory, then you need to do a git pull to get the latest updates. All right, and this is a file that we've seen in a previous lecture, app.yaml. This is a service plus a deployment in one file. So it's technically two resources are created with one apply command, and they're related. The service uses a selector, which we haven't talked about yet, but selectors are how one object finds the resources that it wants to talk to or do something with. So a service needs to talk to pods, so it needs to find a way to get to those, and it uses selectors as essentially pattern matching to match the labels, the keys and values there. Now, if I did the traditional dry run here, then all it would do is the client would look at the apply and say, yeah, I'm going to create these objects, right? It's always going to come back and say created. But that's because the apply is not very specific. If you were using an update or a create or a delete command, which again, I don't feel like is a very DevOps-based workflow, those commands would just do a dry run and the update one would say, yeah, they're both going to be updated. But it doesn't really know on your cluster, right? It hasn't talked to the server to figure that out. So we want to try the server dry run, which is enabled by default on anything 1.13 and newer. And when I do that, it will then go talk to the server and give me a proper response. So let's go ahead and create this. I'm going to take off the server dry run. And this will create the two resources, the deployment and the service. And now if I hit the up arrow and go back to server dry run, you'll see that it says unchanged for both of them. So it's not telling me what changed or if there was something that was going to change, what it would be. It's just telling me that a resource will be changed or not changed. It's sort of a toggle, yes or no. So what about getting the actual difference between what we want to give the server and what the current status is of our resources? And that is the kubectl diff command. And if I simply give it a diff instead of an apply, it will compare the YAML I have to the spec that is in the server's now running, and that status comes back and it will do a diff on that. So let's do that. It'll say nothing because there is no difference. But what if we go change the YAML? So what if I change the replicas to 2 and then I add a label in the metadata and I'll give it something like that, servers DMZ. Just I made it up, doesn't really matter. And then we have the replicas of 2. If I do that same diff, it comes back with the pluses and minuses. So if you're used to reading diffs, this makes perfect sense to you. If you're not used to diffs, the minus means that line would go away, and then these lines would be added. And then down here, it shows you what line and what character in the line that this is being removed and this is being added. So it's keeping the YAML formatting, which is nice, and it's letting us know that multiple changes are happening. Great. And of course, this isn't really doing something like a canary or test deployment or anything. It's not trying to do the thing and then seeing what the result is. It's really just looking at the specification it has on record and the specification that we have on our disk. So check for more info on that on the resources links. It's a blog article from the Kubernetes team on the future of these and how they're going to play out as they come out of beta. And remember, these features right now are beta, at least in 1.15 they are. So hopefully with that, you can create your own workflow for creating YAMLs from scratch, managing the specs in those YAMLs, and then using the apply command over and over to make your changes And that's a much more DevOps friendly infrastructure as code type of way of doing it. Everything you do is documented, hopefully in Git. So you're hopefully making a Git commit for each change you make in your YAML before deploying it to the server. And then you have that nice documentation in Git, as well as the documentation when you do something like a diff to see what you have versus what's actually running. There are two pieces of metadata in this YAML that you probably have seen in the examples and thought about, wondering what labels and annotations are really there for, but you probably didn't realize their significance. And they're a key component of Kubernetes and how things connect to each other, much more so than Swarm. And the first one is labels. Labels go under the metadata key in the root of the file, so they're optional there. You don't have to put them, but they are a key value or a list of key values underneath the labels heading, and those are there for multiple reasons. They're not always required, but you may need them for selecting the objects, grouping them, and even filtering them later on. And this can be anything that describes the object or the resource. It can be a key value pair that the value is simply true or false. The keys can be whatever you want. There just can't be more than one key in each object, so you can't have two keys in a row in the YAML for the same object that have the key name of, let's say, app, right? And these are used really to describe the object. These resources that we're creating have different properties to them. Maybe it's the environment, like prod, dev, or test. Maybe it's the location, like DMZ or backend or frontend. Maybe it's the app name, or maybe it's the client name if you're hosting client sites or something. It could just be whatever you want, and there's not a whole lot of standards. The Kubernetes documentation listed in the resources here does give you some examples, but those are just examples. There's not a whole lot of standards in the industry. It's really up to your team and your company about how you want to describe this thing. And we also have annotations, and they're sort of a yin and yang. The labels are very simple. They are very limited in size and what characters you can put in them, and they're meant to describe the resource. With annotations, this is for more complex data and multi-value data, stuff like that. And you'll usually see annotations used when you're adding custom stuff into Kubernetes that can talk to Kubernetes and get data out of it. So the annotations are there to maybe store config data, like proxies and ingress stuff can often store different configurations inside different annotations. And so those are not necessarily there for describing, but more for configuration. But let's go back to labels for a minute, because there's a lot more to that that's key to understanding how all this stuff works in Kubernetes. And the first thing is that we can do simple filters by limiting to the labels from the command line. So we can do a git pods and just say, only show me the pods with this label. And you can even use a comma there to add multiple labels. And in fact, there's a whole level of syntax to this thing where you can do different types of syntaxes, different ors and ands. And really, it's one of those things where I don't want to teach you all that, because it's going to be like learning regex. It's something where you won't really learn it by just trying it once. It's only when you need it that you're really going to understand it. And the documentation from Kubernetes is really great. They've got multiple links I've put in the resources that will take you through the path of all the different ways that you might need labels. And quite frankly, you don't really need to learn that until you know you need it to solve a problem. And you can even use it for apply commands. So if you had a whole bunch of stuff in one big YAML file and you only wanted to apply certain parts of that YAML file, I don't do this a whole lot, but it is there where you could limit to say only apply the changes or information that you've put in the YAML for specific labels. And of course, again, with this one, you can put the same syntax. You can just have a single label. You can put in commas to have multiple labels and values there. So it's up to you. But there's another thing that the labels do that's important to how Kubernetes works. And it comes down to there are certain resources that talk to other resources or connect to them or are related to them, however you want to say it. And the good example is the services need to know which pods to send their traffic to. And you might wonder, how does it know? I mean, when you type it in, if you do a kube control service command and you're pointing it to the deployment, what exactly is it using to identify that deployment? Well, in the CLI, you would think that it's actually pointing to the deployment object, but really the service needs to talk to the pods, not the deployment itself. And it's using something called label selectors. And this is common with lots of the different resources that are higher levels of abstraction of pods. For them to relate to the pods or to know which pods are theirs, they use label selectors. So you will see that in the YAML inside our repo that you've been using for the last few lectures. And if you look in the app.yaml, you'll notice that all along we've had a couple of things in there that we haven't talked about. The first one is at the top part with the service, we have under the spec a selector, and that has to be there. And we're telling it the key and value of a label for pods that it needs to direct traffic to. So that's just a simple match. It needs to find pods with that. And then down in the deployment underneath, you'll see that our spec has its own selector, match labels, app, app nginx. And what's happening there is both of those objects are selecting pods based on that match. That means in the template under our spec where we're templating out the pods, that needs to have that label in it so that those resources can find their pods. And the nice thing is in the later versions of Kubernetes is that at least with just a single deployment, these have to be in sync. It'll actually fail a deploy if it sees that the selector match labels isn't matching the template metadata labels because they have to in order for it to even deploy the pods and be able to control them. So it's there to kind of prevent you from accidentally doing it the wrong way. And it'll expect you to have those pieces in there. In older versions, there used to be a way where it would automatically generate them by default so you could leave the stuff out, but they've stopped doing that now and they force you to put this in there. And I think that's a good thing, especially how important these label selectors are. Now, technically, if you went back to Swarm, Swarm does a little bit of this out of the box where it has labels that match things up from stacks to services and stacks to their volumes and stuff like that. But we don't really get to control it and we don't see it a whole lot in the interface. It's kind of done in the background for us in Swarm. But it's also very limiting. You can't change things on the fly. You can't necessarily go and customize those for really unique setups. Here, we could possibly have a service talk to multiple deployments if we wanted to change those selectors. And selectors aren't just about linking resources together. It's also about controlling where they go. So on the nodes, you can use labels and selectors to control where they go. And you can use even further customization with things called taints and tolerations that are sort of the inverse of that, where you're telling nodes that they can't do certain things so that Kubernetes knows where to basically control where your pods go. And these things get really custom and really advanced pretty quickly. So doing them all together can get a little bit hairy and crazy. So I definitely recommend that you take it slow with them, keep it all simple out of the box, and avoid taints and tolerations until you really need to look into those. All right, let's clean up for this whole section. So if you have anything running in the default namespace for your cluster, if you just do a kube control get all, and you see stuff there beyond the Kubernetes API itself, then go ahead and delete all those resources because we're going to be moving on. We won't need those.